time. Some of the folks on this call have been in longer than me, but I started working for Green parties in the late 90s, and that's been my journey. But for the last 15 years or so, um, Trillium has been um, trying to tackle the problem through working with bigger organizations um, and about 10 years ago, one of our clients became NASA, and we started working on AI. Um, so the title of my talk is Welcome to the Intelligence Age, because I think, more or less we are in it. And that description, very sort of multifaceted, complex, nuanced setup that from the discussions we've just heard sort of shows that we're in a very difficult period. And I think everyone on this call will know that. AI is like electricity and oil itself. It's a horizontal technology. It's going to be in everything. We used to joke about it being, stuck on the side of fridges, and but it is, going to be powering everything we touch, from the cars we drive to the prompts and the things we put into applications. And the reason why it's creating so much these sort of turbines of wealth and speculation in the stock markets is because people realize it's an opportunity to create vast wealth and define the next century, and that's really the battle that's happening. But in this talk, I wanted to also provide some positive context. And, one of the things we do is run the Earth System Lab with ESA, which is another AI lab. And one of the cool things about working with ESA is they are by far the best stewards of Earth data, looking down on the planet. They have this is one of the fantastic contributions that ESA makes. They have essentially the world's best observational fleet of actually how the world is changing. And all that data is open, and we can use that data to really understand what's going on. For example, we can look at floods, and our some of the machine learning that we developed using ESA data became the official flood maps of the Australian floods a few years ago, and the Valencia floods more recently. But this is a potentially for good use of machine learning or AI to support disaster response. And this particular use case I'm showing is the application of actually putting intelligence on board satellites to make this feedback even faster. So rather than waiting hours, we can get insight on what's actually happening on the ground within seconds, and that's kind of the direction of travel for a lot of these technologies. Another thing we can do is use satellite technology to measure emissions, carbon emissions, and we proved for the first time that you could use satellite derived machine learning to start measuring methane plumes. And this research was then picked up by the UN, and they've created the Methane Observatory, which is currently collecting all of the erroneous methane plumes. Again, an application of machine learning for good. What's interesting is that even though we did the academic work to prove this was possible, the actual deployment of the system was paid for by Jeff Bezos. So it's very interesting, this world we're in at the moment, because we use uh, and this is not to discredit the speakers before me, but it's easy to demonize. And I think in these situations where it's very nuanced, we need to be very clear on who we're pointing the finger at. I completely agree that uh, the space tourism and the sort of stuff that Jeff Bezos has been paying for is ridiculous, and there's also a whole lot of environmental downsides about delivering particulates to the upper atmosphere. But at the same time, he's one of the biggest contributors to climate research. So it's a very difficult subject, and I just wanted to highlight that. So the technologies that are sort of for good are a lot of them are being unlocked by the same revolution that's happening in um, language foundation models, the sort of things that everyone's been playing with, like ChatGPT and Google Gemini. These are actually specifically called vision language models, but essentially the technology is the same. And these are these enormous models which essentially start to learn patterns in the data. And so, why they are magical is that the sorts of connections that we might have, have associated with certain concepts, these models also share these connections. And so, for example, buying a Porsche, there's a shorthand for midlife crisis. These models start to know these shorthands, these connections in the latent space, and this is why they seem quite magical when you use them, but also um, we have human beings are helping with completing this illusion of mind because the way these things are presented in the chat interface, we tend to complete the step and start thinking that we're actually talking to a another being. But to be clear, these are statistical tools, and they're just really predicting these concepts in a way which seems logical, and we then imbue that there's such something behind them. But clearly, it's been a revolution. And we build foundation models for science use cases. And so this is to say that even though the revolution is really focusing on foundation models for text and language, there's also foundation models. And so you can see here, this is this chart showing the evolution of language models, and then vision models, but also geospatial models, some of these ones which we've been involved with, and also heliophysics models and lunar models and things like that. And essentially, just like we saw with language models, these systems are growing. A few years ago, NASA released Prithvi, which was the first real geospatial foundation model, certainly the one that got global traction. And then a few years after that, the Clay Foundation released one, and then Google DeepMind released another one called Alpha Earth recently. Each time they're getting bigger and more capable. But what's sort of interesting about them is it allows us to talk to the data. So we can start applying natural language. And so instead of taking weeks to get to a data outcome, we can then just query the foundation model. And this is what this chart is showing, is that in natural language, we can, for example, ask a solar foundation model what the sun is doing and then get a weather forecast of the sun in natural language. And again, this is potentially hugely powerful for predicting solar flares and some of the deleterious things that the sun can throw at us. And that's a much larger discussion than my 10 minutes. But why this is exciting is we think that we can now start to query Earth data, the sort of incredible combination of sort of data that's coming from space, and start to do this thing called Earth system predictability and use natural language to start querying the state of the planet. And that if we can do that more effectively, then perhaps we can start to use these capabilities to start tackling some of these problems that we're faced with, climate and social inequality and those sorts of things. But to do that, we also need to learn how to trust AI. And one of the things we've been working on recently is the ability to um, uh, understand when a foundation model doesn't know something. So imagine if you're using ChatGPT, and we all know that one of the problems with these technologies is they hallucinate. Imagine if the text changed color, and if it was unsure, it went orange, and if it really knew it was fibbing, it went the text would go red. This essentially is what this capability does. And you can see here, looking at, in this case, it's burn scars in the United States, and you can see that the model is saying, listen, I just don't know enough to feel confident about that. And so we're getting to the stage where we can start to potentially trust these AI systems more. But just in closing, I wanted to talk about really the problem of AI monopolies and this if we're caught napping this sort of transfer of wealth and power to organizations that potentially will strip us of our the sort of the lifestyle that we have, and but also the sort of cultural implications as well. And this is this problem of having data energy GPUs and these massive models domiciled offshore, and it's really just a massive transfer of wealth and culture, which we've already seen in the last 10 years with Web 2.0 and the speaker before mentioned Netflix and Disney and all those sorts of things. We are giving away um, our national capabilities to these cyber elites. Um, we can domicile compute here in the UK, and that would be a step in the right direction, but we're still transferring culture offshore. Really, the ideal, as I see it, is that we are starting to export um, models, capabilities to the owners of these big systems, which is what this chart is trying to show, by having unique investing in unique data, local compute capabilities, and our own local domiciled foundation models. And that by doing this, we can at least create an export of intelligence and retain our culture to a certain degree. And so, just in closing, would be my sort of response to kind of this reality that we're facing, that we start building our own foundation models that sound like us and reason like we do, that also sanity check the decisions that are being made using methodologies like I just showed, and that our UK services are certainly informed by local machine learning, our AI systems, but also that we can start building our own unique capabilities, our own foundation models that we develop based on our data, and that these systems can be then exported and inform the bigger models that are owned by the bigger capabilities. And that if somehow we can do these things, we can play a role in the intelligence age and not be on the receiving end of these enormous changes to come. So with that, I'll give the floor back to our host, and hopefully that was useful.
James, that